This is no ordinary 747. It carried no passengers, just a weapon straight out of science fiction. The Boeing YAL-1 was built to shoot missiles out of the sky using a giant laser cannon. But what happened to this futuristic but experimental flying weapon? Let's go behind the story of the Airborne Laser and why it disappeared. The Boeing YAL-1 was one of the most ambitious and futuristic weapons projects the US ever tried to build. A modified Boeing 747-400F turned into a flying anti-missile laser cannon. Originally developed under the US Air Force's Airborne Laser (ABL) program, the YAL-1 was part of a wider effort to build a defense system capable of intercepting ballistic missiles during their boost phase, that crucial moment just after launch when the missile is still climbing and burning fuel. Inside the aircraft was a massive megawatt-class chemical oxygen iodine laser, or COIL. This wasn't just some laser pointer. It was a gigantic, high-powered laser that filled most of the aircraft's fuselage, built to vaporize missiles mid-air from hundreds of kilometers away. But shooting that laser was only part of the system. The YAL-1 also had two low-power tracking lasers and infrared sensors to detect and lock on to the heat signatures of launching missiles. Once a threat was detected, it used those tracking beams to pinpoint the target, then fired the high-energy beam to destroy it, all in mid-flight. The front of the aircraft was redesigned with a giant turret-like nose that housed the laser beam director. It could swivel and aim with precision, giving the aircraft the ability to target missiles while flying at altitude. In theory, the concept was groundbreaking. If successful, it would give the US the ability to shoot down enemy ICBMs within seconds of launch, before they could even leave their own airspace. The YAL-1 was part of a larger missile defense vision under the US Missile Defense Agency in the early 2000s. Boeing was the prime contractor, with Northrop Grumman providing the laser and Lockheed Martin building the beam control system. The first test flight was in 2002, and by 2010, the YAL-1 had successfully shot down 2 test missiles in flight, which was a historic achievement. But here's where things got complicated. Despite the successful demos, the laser had very limited range, and it required the aircraft to fly dangerously close to hostile territory to be effective. Not only that, but the COIL system required huge amounts of chemical fuel to generate each shot, which made it hard to reload, expensive to operate, and logistically impractical in combat. It also turned out the laser couldn't penetrate some newer missile casings or thicker fuselages reliably. And when you're flying a 747 near enemy airspace, you're a big, slow-moving target, vulnerable to anti-air weapons and fighter intercepts. By 2011, the YAL-1 was canceled, with the Pentagon citing its cost, limitations, and lack of real-world practicality. The program had already cost nearly $5 billion, and it was ultimately decided the system wasn't worth the price tag or the operational risks.